Hello everyone, welcome to Geeky Nerd. Today we will begin with the part 2 video of the aptitude topic problems on trains. Before moving into this video, I hope everyone would have become thorough with the part 1 video of this aptitude topic. Problems would have been solved via both the traditional as well as the formula method. If you have not seen the part 1 video, please click on the card or the link in the bio. In this video, we will be discussing two of the interesting concepts such as trains crossing moving negligible objects and time taken by the trains to cross each other. Like, share and subscribe the channel for more interesting concepts and shortcut methods for solving them. Without wasting any time, let's move into the video. Train crossing a moving negligible object. We know that in the part 1 video, we dealt with two cases, namely train crossing a stationary negligible object and train crossing a stationary object whose length is not negligible. So here, the object which the train crossed was stationary, whereas in the part 2 video which we are discussing currently, the train will cross an object which will be in movement and not in stationary. Whenever a train crosses a negligible object, the length of the object will not be considered. Therefore, the distance traveled by the train will always be equal to the length of the train. But here, the train is crossing a moving negligible object. Whenever an object moves, it will have a speed to it, and hence, since speed of the train and speed of the object are involved, we need to calculate the relative speed. When the object and the train are moving in the same direction, then the relative speed can be given as speed of the train minus speed of the object. When the object and the train are moving in the opposite direction, then relative speed can be defined as speed of the train plus speed of the object. So now we know distance traveled by the train to cross the object and the relative speed. Thus we can find the time taken by the train to cross a negligible object which is moving as distance traveled divided by speed, that is length of the train divided by relative speed. Let us solve few examples to understand this. 440-meter long train is running at 240 km per hour. In what time will it pass a man running in the direction opposite to that of the train at 24 km per hour? So from the question, we can clearly see that a 440-meter long train is running at 240 km per hour. In what time will it pass a man running in the direction opposite to that of the train at 24 km per hour? So we know that length of train LT is equal to 440 meter. Since it is crossing a man, length of the man will be negligible. And we know that speed of train is equal to 240 km per hour and speed of man equal to 24 km per hour. From the question, we can clearly see that both the man and the train are traveling in opposite direction. Therefore, relative speed is equal to speed of train plus speed of man, which is equal to 240 plus 24, 264 km per hour. Now we know the length of the train and we know the relative speed. Thus we can substitute it directly in the formula. Time taken by the train to cross a man is equal to distance traveled by the train to cross the man divided by speed of the train plus speed of the man in this case, that is relative speed. So we know that length of the train as 440 meters. So since it is in meter, we can convert speed in kilometer per hour into meter per second by multiplying by pi by 18. Therefore, 18 into 440 divided by 264 into 5. Upon solving, we get 18 by 3, which is equal to 6 seconds. Therefore, the train takes 6 seconds to cross the man who is running in the opposite direction to that of the train. Let us solve one more example. A 400-meter long train takes 36 seconds to cross a man walking at 20 km per hour in the direction opposite to that of the train. What is the speed of the train? So from the question, we can understand that length of the train LT is equal to 400 meter. Time taken is equal to 36 seconds. Speed of man is equal to 20 km per hour. Speed of train equal to question mark. We know that the basic formula of speed is speed is equal to distance traveled by time taken. Here, since train and a moving man is involved, we have to calculate relative speed. Relative speed is equal to, formula remains the same, that is distance traveled, that is 400, the length of the train, divided by time taken, that is 36 seconds. So upon solving, we get it as 100 by 9 meter per second. If we want to convert it into kilometer per hour, it becomes 100 by 9 into 18 by 5. Upon solving, we get 40 km per hour. So, from the question, what we can identify that relative speed is equal to speed of train plus speed of man. Since both of them are walking to opposite direction, therefore 40 is equal to st plus 20, which in turn gives speed of the train as 20 km per hour. Thus, we have calculated speed of the train as 20 km per hour. Two trains crossing poles, time taken to cross each other. Here let us consider two trains whose lengths are same but they travel with different speeds. Since they travel with different speeds, they take time t1 and t2 to cross the pole. Now, if t1 and t2 are the time taken to cross the pole, then we need to find the time taken by the train to cross each other. Therefore, the time taken by the train to cross each other can be given as 2t1 t2 divided by t2 plus or minus t1. Here, plus symbol will be used when the trains move in opposite direction and minus symbol will be used when the trains travel in same direction. As far as till now, we saw the case of two trains having equal length and different speed. Now we will see the case of two trains having different lengths but same speed. If two trains having different lengths and same speed travel in the same direction, then it is not possible for them to cross each other. When two trains having different lengths and same speed travel in the opposite direction, then the time taken for them to cross each other can be given as total length divided by the relative speed. Let us solve some examples to understand this concept. Two trains of same length but different speeds pass a static pole in 4 seconds and 5 seconds respectively. In what time will they cross each other when they move in same direction and in opposite direction? We know that two trains are of same length. the time taken by train 1 to cross the static pole is equal to 4 seconds and time taken by train 2 to cross the static pole is equal to 5 seconds. We need to know the time taken by them to cross each other if they travel in same direction as well as when they travel in opposite direction. We know that time taken to cross each other is equal to 2t1 t2 divided by t2 minus t1. Since as per the theory of relativity, when trains move in same direction, relative time also decreases. Therefore, T2 minus T1 and hence on substituting we get 20 seconds. Now, let us compute the time taken by them to cross each other in opposite direction. Time taken to cross each other is equal to 2t1 t2 divided by t2 plus t1. Since they move in opposite direction, time gets added. Therefore, on substituting, we get 40 by 9, which is equal to 4 by 9 seconds. Thus, we found out the time taken by the trains to cross each other in same direction and time taken by the train to cross each other in opposite direction. Through this video, I hope the listeners would have understood the two concepts trains crossing moving negligible objects as well as the time taken by the trains to cross each other. Problems were solved via both the shortcut as well as the traditional method. I insist all the listeners to practice solving more and more problems to increase their confidence. Like, share, and subscribe the channel and convey it to your friends so that they can also be benefited. Until we meet in the next video, thank you.